Welcome back, everybody. Go ahead and open your math notebook. You can write down today's title. Today we're going to talk about factors, common factors, and greatest common factors. So go ahead and turn the page from yesterday. Write this as the title of the next page in your math notebook. After you have done that, close your math notebook, put your pencil down, and unpause and just concentrate with me until we get to the we do section. All right. So yesterday we talked about multiples and least common multiples and common multiples. So just as a quick reminder, if we talked about, say, the multiples of 10, those were 10, 20, 30, 40, 50, 60, and so on. If we talk about, say, the multiples of 5, those are 5, 10, 15, 20, 25, 30, and so on. And we looked at two special circumstances comparing those yesterday. We looked at common multiples. So you'll notice 10 is a common multiple, 20 is a common multiple, 30 is a common multiple, and so on. Those are multiples they had in common, that they had the same. And then we especially paid attention to the least common multiple, which in this case would be 10, because that was a special answer to some problems, like when we looked at George Banks' hot dogs and buns. That was like the least number he could buy and still match up and not have to open any packs up like a crazy person in the store. So similar language today. We're going to talk today about factors, common factors, and greatest common factors. So you'll notice a lot in common with what we did yesterday. So you learned about factors also in fourth grade. So if I wanted to look at two numbers and check out their factors, let's say I decided to look at the numbers 20 and 48. Why don't I do that? So the factors of 20, the multiples of 20 are counting by 20s. The factors of 20 are the numbers you can multiply to get 20, and they come in pairs. For instance, you can do 1 times 20. Those are factors of 20, 1 and 20. You can also do 2 times 10. You can also do 4 times 5. And I think those are all the ways you can make 20 by multiplying. 1 times 20, 2 times 10, and 4 times 5. And at that point, you have all of the factors of 20. So those are 20s, what are called factors. Now, one tricky thing with factors is you probably know all of these by heart. You know 1 times 20, you know 2 times 10, you know 4 times 5. One tricky thing with factors is you have to remember ones that you may not have ever memorized. So like when I start trying to do the factors of 48, 1 and 48 are definitely going to be factors. And you might be able to look at this and say, oh, I can tell that's 2 times something because it's even. And it is. That's actually 2 times 24. You don't know your 24s. I know you never memorized your 24s when you were in fourth grade, but I just want to point out you've got to do it that way. You've got to check all these numbers. So what I do is this. So I say, okay, I'm going to check 2. Now I'm going to check, is 3 a factor? Is 3 times something 48? Well, I don't know any 3 times something is 48, but it actually is. If you try dividing, 3 times 10 is 30. And that leaves me with 18 left. And then 3 times 6 is 18. And I get no remainder. So actually, 3 times 16 is 48. And you probably wouldn't have seen that if you didn't check. And that's one of the hard things with factors is there's going to be numbers you don't know that are factors. So you've got to keep trying things. You probably know 4 times 12. So that's also a set of factors. Let me try 5. 5 times nothing is 48. 6, what about 6? 6 times 8 is 48. And here's how I know when I'm done, right? 7, let's try 7. Can I divide 48 by 7? You probably know you can't, right? Because 7 times 7 is 49. And so 7 times nothing is 48. And so the next thing I would try is 8, but 8's already on my list. And once I get to something already on my list, I know I'm good. I don't have to do it anymore. So here's my list of factors of 48. Has a lot. I picked 48 on purpose because it has a lot. So that's factors. So the next thing I'm going to look for is common factors, right? Do they have any factors in common? They do. They both have 2. They both have 1. They both have 4. And that's it, right? That's it. So they have 3 common factors. So I would say the common factors of 20 and 48 are 1, 2, and 4. That's their common factors. And last but not least, you'll notice I often ask about the greatest common factor. That's going to be a special answer to some questions. Yesterday we looked at least common multiple. Today we're looking at greatest common factor, and that obviously in this case is 4. Okay, so let's talk about why that matters in problems. So let me invent a problem for you here. It says, I want to make prize bags to give out to deserving students, which I spelled wrong. Deserving students. I have 45 Skittles and I have 30 Starbursts, and I want to make a bag that has an equal number of Starbursts. I want to make bags that have an equal number of Starbursts, which I also spelled wrong, and an equal number of Skittles in each bag. Right? For example, I could have a bag with 5 Skittles and 4 Starbursts in each bag. I want all the bags to match, and all the bags to have the same number of Starbursts in each bag, and the same number of Skittles in each bag, but you'll notice those numbers don't have to match. They don't have to have like 4 of each or 5 of each. I just want to divide them evenly. So I want to take my 45 Skittles, put them in bags. I want to take my 35 Starbursts, put them in bags that are even. That's what I want to do. It says use common factors to figure out the possible number of bags I can make. All right, well, let's start with my Skittles. Make this less complicated, right? I've got 45 Skittles. So how can I divide those up evenly into bags, right? Well, I'm going to use the factors to find out. First of all, 1 and 45 are factors of 45. So that means I can make one bag with 45 Skittles in it, or I could make 45 bags with 1 Skittle in each bag. That's a possibility. It's kind of a lame possibility, but it's a possibility. What are some more factors of 45? 2 is not. 3, let's try 3 real quick. 45 divided by 3. I know 3 times 10 is 30. And I know 3 times 5 is 15, which leaves me right to 0, so it does work, right? I can do 3 times 15. So those are factors. So what that means, I can make 3 bags, and each bag would have 15 Skittles, or I can make 15 bags, and each bag would have 3 Skittles. That's what that means. 4 does not go into 45. 5 does. 5 times 9 is 45. 6 does not. 7 does not. 8 does not. And 9's already on my list, so I know I'm done. So there's all the possible ways I can do my Skittles. I can put them in 1 bag, 3 bags, 5 bags, 9 bags, 15 bags, or 45 bags, and they would be even, equal. What about my Starbursts? I'll just call them bursts. So of those I have 30. So what are my factors of 30? They're going to help me solve this problem because I want to divide them equally. That's what factors are. What can I divide 30 by equally? Well, I can do 1 and 30, obviously, to make 1 bag with 30 Starbursts or 30 bags with 1 Starburst. I can also do 2 times 15. So I could take my 30, divide them into 2 bags. Each would have 15, or divide them into 5 bags. Each would have 2. I can divide them into 3 bags, and each would have 10, or 10 bags, and each would have 3. 4 does not go into 30. 5 does. 5 times 6. And then 6 is my next number to try. It's already on my list. I'm done. So I can divide my Starbursts into bags of 1, 2, 3, 5, 6, 10, 15, or 30. So looking at the common factors here, what can I do? I can do 1. I can do 3, 5, or 15. Notice those are in common, right? So here's what I know, right? The first thing that tells me is I can do, the ones tell me I can do 1 bag, and it would have everything, right? It would have all 45 Starbursts, and it would have all 45 Skittles, and it would have all 30 Starbursts. 3 they have in common, so I can do 3 bags. If I do 3 bags, they're each going to have 15 Skittles, and they're each going to have 10 Starbursts. I can do 5 bags. If I do 5 bags, they're each going to have 45 divided by 5 is 9. And 9 Skittles, and they're each going to have 6 Starbursts. Last one I can do is I can do 15 bags. And if I do 15 bags, they're each going to have 3 Skittles, and they're each going to have 2 Starbursts. So that's my possibilities, right? So there's one last thing. So that's all the possible ways I can divide the bags up and have the same number of each kind of candy in each bag. Notice last, this is my greatest common factor right here. Greatest common factor. And so the point of that one is that's the most bags I can make. And that's often the thing I want to know. What's the most bags I can make out of this? And the most is 15. All right. Go ahead and open your math notebook. We're going to do one more together. I'm going to have to go a little faster, so be ready to pause if you need to. I'm a little short on time. Let's go ahead and pause now and write this problem down, and then unpause and I'll work it out with you. So it says a group of 50 children and 20 adults came to the park for a scavenger hunt. Leader wants to make groups with an equal number of kids and an equal number of adults. For example, each group could have 8 kids and 2 adults. That's not a real possible answer. That's just how I want you to think of it, right? Divide the kids evenly, divide the adults evenly. So what are the different combinations we can make? So let's start with factors, right? The factors of 50 are, I'm going to do these fast. I need you to know how to do this, but I'm going to do these fast because I'm short on time. So the factors of 50 are 1 times 50, 2 times 25, 5 times 10, 6, 7, 8, 9, 10, and 10's already on my list. So that's them. And then the factors of 20 are 1 and 20, 2 and 10, 3, 4 and 5, and then 5 is on my list, and that is those. Right, so that's the different numbers of ways I can divide the groups of kids and adults up. So let's look for what's in common. 2 is in common, 5 is in common, and 10 is in common. So those are the numbers of groups I can make. So let's talk about how those are. So one thing I can do is I can make 2 groups because they have 2 as a common factor. If I make 2 groups, each group is going to have 25 kids. 2 times 25 is 50 kids. And 10 adults. Each group will have that. Those are a pretty big group. I may not be into that idea. So the next thing I can do is I can make 5 groups. Right? Another possibility is I can make 5 groups. If I make 5 groups, 50 divided by 5, that's going to be 10 kids in each group. And 20 divided by 5, that is 4. So it's going to have 4 adults in each group. That's another possibility. I use the factors to do that. Last possibility is I can make 10 groups. And if I made 10 groups, they would each have 5 kids and 2 adults. So those are my possibilities, right? The common factors help me find the numbers of groups I can make with the adults and the kids. Last thing to maybe pay attention to, this is the greatest common factor is 10. Greatest common factor is 10, and that means 10 is the most groups I can make. If that was my goal, to say what's the most possible groups, I want to use the greatest common factor. So that is how factors, common factors, and greatest common factors work and how they help you solve problems. I hope this made sense to you. I did have to kind of rush there at the end. If this didn't make sense to you, a good thing to do now would be to go back and watch the I do or the we do again a second time so that you see it again and hopefully are able to make more sense of it a second time through. Once you have written down your we do and you feel confident that you understand it, then you are all set, and I'll see you tomorrow.